Welcome to my channel. My name is Ali and I'm going to be going through this GCSE maths probability question. A class contains X female students and Y male students. 2 students are selected at random. Draw a tree diagram to represent the information. So firstly, I think it's best to write down all the information that you're given in this question. Let X equal the number of female students and Y equal the number of male students. Then from there, X plus Y equals total students. We've already got the structure of the tree diagram laid out here for us. These first branches represent the first choice, so we'll write that in. And the second branches represent the second choice. The different directions that these branches go represent whether it was a female or male student which is chosen. So I'll write that in as well. So this shows a female student being chosen, then either another female or a male. And I'll do the same thing on the other side. Again, that's a male student being chosen, then a female from there or a male from there. And together, I'll write in these options at the side. This is 2 females, a female then a male then a female, or 2 males. Now we need to write in the probability of each student being chosen. So let's start with female. If X is the number of female students, we want to find out the probability of X being chosen out of the total. So this would give the probability of a female student being chosen first as X over X plus Y. The probability of a female student being chosen at the first choice is X over X plus Y because there's X female students and the total number of students is X plus Y. For the second choice, we're assuming that this student is then removed, so this student cannot be chosen again, meaning that there is one less female student to choose from, and then there's one less from the total for us to choose from. If a male student is chosen next, there's the same number of male students for us to choose from. However, there's one less from the total number of students, since one has already been chosen. And it's the same on the other side of the tree diagram. There's Y male students, and the total number of students is X plus Y, and that means the probability of a male student being chosen first is Y over X plus Y. The probability of us choosing another male student would then be Y minus 1, because there's one less male student, over X plus Y minus 1, because there's one less in the total number of students. If a female is chosen, we would have X, which is the number of females, over X plus Y minus 1, because there is one less from the total number of students in the class. And that is the tree diagram finished. The second part of this question asks us to find, in terms of X and Y, the probability of choosing 2 female students and 1 of each gender. So let's start with the first one. The probability of choosing 2 female students is the probability of getting F on our tree diagram. We can use the AND rule of probability to work this out. This tells us that the probability of 2 events A and B occurring is equal to the probability of A times the probability of B. This means that the probability of choosing one female student and then another female student right after is the probability of choosing a female student for the first choice multiplied by the probability of choosing a female student in the second choice. So we can use our expressions for these different probabilities, multiply them together, and get the probability of them both occurring. The probability of choosing a female student in the first choice is x over x plus y, and the probability of choosing a female student on the second choice is x minus 1 over x plus y minus 1. And we can multiply this out to get the probability of choosing both of them. Here it's best to leave our expressions in factored form, as this is the simplest form we can get to. So this would be your answer. The second part of the question asks us to find the probability of choosing a student of each gender. Referring back to our tree diagram, we can see that here, when a female student is chosen first and then a male, that we are choosing one of each gender. And the same is achieved when a male is chosen first and then a female next. To find the total probability of choosing one of each gender, we must add our results from multiplying this branch and this branch. So we can write MF plus FM is the expression that we're looking for. MF can be given as y over x plus y multiplied by x over x plus y minus 1. Again, using our AND rule for probability. MF can be given as y over x plus y multiplied by x over x plus y minus 1. And Fm, the probability of choosing a female first and then a male, can be given as x over x plus y multiplied by y over x plus y minus 1. We can multiply out this algebra. Because these terms have the same denominators, we can add them together. And that's our solution. The final part of our question reads as follows. The probability of 2 male students being selected is 2/15. If there are 8 male students in the class, how many students are there in total? So here we can use our AND rule for probability again first to find out the probability of 2 male students being selected. This can be found by multiplying y over x plus y by y minus 1 over x plus y minus 1. Which gives us again, we can leave this expression in this factored form because it's the simplest form for us to work with. We're told this equals 2/15. We're also told that there are 8 male students in the class. Originally, we had defined y as the number of male students. So we can set y equal to 8 now. And substitute y equals 8 into our expression to get this can be simplified to 56 over x plus 8, x plus 7, and this equals 2/15. And to solve for x, first it is easier to remove the denominators. We can do this by multiplying by 15 and then multiplying by x plus 8, x plus 7. On the left-hand side, multiplying by x plus 8, x plus 7 removes this denominator, but we multiply by 15 to give us 15 times 56. Then on the right-hand side, we multiply by 15 to remove the denominator, which leaves us with 2 multiplied by x plus 8, x plus 7. Now, 15 times 56 gives us 840, and this is equal to 2 times x squared plus 15x plus 56. We got this by multiplying these two brackets together. We can use our FOIL method to give us x squared plus 15x plus 56. Next, we multiply the right-hand side by 2, and we get 2x squared plus 30x plus 112. To solve this quadratic equation easier, we want to set it equal to 0, and to do so we can subtract 840 from both sides. And we get 2x squared plus 30x minus 728 equals 0. To simplify this equation, make it easier to solve, we can divide it by 2. X squared plus 15x minus 364 equals 0. Here we divide the left-hand side by 2 and the right-hand side by 2, giving us this expression. This can be factored to x minus 13, x plus 28 equals 0, which gives us the solutions x equals 13 or x equals minus 28. X is a number of people. Therefore, x has to be greater than 0. Because we're talking about the number of people within a class, x can't be negative. So that means the only valid answer is x equals 13. At the start of the question, we formed an expression for the total number of students, which was x plus y. And we want to find the total number of students. Now we have a value for y, which is y equals 8 over here, and a value for x, which is x equals 13 over here. So we can write over here, total students equals x plus y, which is 13 plus 8, which is 21. And this is our final answer.